This is a lesson on similar solids. In similar solids, the ratio of volumes is related to the ratio of the size. And we can use this fact to solve for unknown volume, surface area, and site. We will also look at the ratio of masses of similar solids. We begin by looking at some useful facts. In these two similar solids, the ratio of these two lengths, e.g., is half. The ratio of the corresponding lengths, AC, is also half. In fact, the ratio of any pair of corresponding lengths is half. Similarly, the ratio of the perimeters of the triangles is half because the perimeter is also a length. Similarly, the ratio of the areas of the triangles is 1/4 and the ratio of the base areas is also 1/4. Once again, the ratio of any pair of corresponding areas is 1/4. This includes the ratio of the total surface areas is also 1/4. You may also notice that the ratio of areas is simply the square of the ratio of lengths. We next look at the ratio of volumes. In these two similar solids, the ratio of the corresponding lengths is 1/3. And if we take the ratio of the volumes, we find that it is 1/27. This means that the ratio of lengths cubed is the same as the ratio of volumes. This led us to the conclusion that the ratio of volumes is simply the ratio of lengths to the cube, or V1 over V2 equals L1 over L2 to the cube. We will now look at some problems. In the first example, we need to find the unknown volume, but we know the corresponding size, which is the radii. Using the formula, ratio of volumes is the ratio of the lengths to the cube. We find that 10 over V2 equals to 1/3 cube, which is 1/27, giving us V2 equals 270 cm cube. In the second example, we do not know the height. Once again, ratio of volumes is the ratio of the heights to the cube. We substitute in the values. Reduce this to the lowest term. We have 8/27, and taking the cube root, we have 2/3, cross multiply and divide by 3. We find that the height is 4 cm. In the next example, we need to find the volume, but we are given the corresponding areas. We need to find the lengths in order to get the ratio of volumes. Thus, we begin by working out the ratio of lengths from the ratio of areas. We have L1 over L2 is 2/3. Now we form the relationship V1 over V2 is the ratio of the lengths cubed. So we have V1 is 16 over V2 equals to 8/27. This gives us V2 is 27 times 16 over 8, which is 54. In the last example, we need to find the surface area of the bigger object. We use the relationship again. Ratio of lengths cubed is the ratio of volumes. From here, we can find the ratio of lengths L1 over L2 is simply 2 over 5. We need the ratio of lengths in order to find the ratio of areas. Ratio of areas is simply the ratio of lengths to the square. The first area is 18. And here we have 4 over 25. The surface area is 18 times 25 over 4. Next, we take a look at the ratio of masses. In similar solids, they are made of the same material, and hence they have the same density. We know that mass is volume times density. Consider these two volumes, mass 1 and volume 1, mass 2 and volume 2. We take the ratio of the masses, and using the formula, each mass is equal to volume times density. Since the density is the same, we can cancel it away, giving us m1 over m2 equals v1 over v2. That is, the ratio of masses is equal to the ratio of volumes for similar solids. And since the ratio of volumes is ratio of lengths to the cube, therefore the ratio of masses is also equals to the ratio of lengths to the cube. We will now look at some problems. We need to find the volume, and using the relationship, ratio of volumes is simply the ratio of masses. Cross multiplying, we have 25 times 6 over 2, which gives us 75 kilograms. 75 cm cube. In the next example, we have been given the lengths, so we need to use the formula ratio of masses equals ratio of lengths to the cube. And this gives us 54 over m2 equals 3/4 cube. And once again, we cross multiply. We have m2 equals 54 times 64 over 27, giving us 128 grams. In the next example, we do not have the lengths. Neither do we have the volumes. We are only given the base areas. We need to find the ratio of lengths in order to find the ratio of volumes. From the ratio of areas, we can find the ratio of lengths, which is L1 over L2 equals 3 over 4. Now we can use this to find the ratio of masses, which is the ratio of lengths to the cube. Ratio of masses is m1 over 16 equals 27 over 64. Therefore, m1 equals 27 times 16 over 64, which when we cancel out, 27 divided by 4, we have 6 and 3/4 kilograms. Finally, we have to find the length, and we know the masses. From the masses, we can find the ratio of volumes. And since the ratio of volumes is the ratio of lengths to the cube, therefore we use the formula ratio of lengths to the cube equals ratio of masses. And reducing this, we have 8 over 27. So L1 over 9 is the cube root of 8 over 27, which is 2/3. And therefore, L1 is 2/3 times 9, which gives us 6 cm. This concludes the lesson on similar solids. Thank you.